So in our last video, we learned about our prefixes and how we can use them in the exponents they represent to convert from one unit to the other. And we did this by comparing to our charts and our formula sheets and the chart that we built ourselves in a previous video. So I believe we started with, for example, I think we said 1 kilogram is how many grams? And then I believe we did the exact opposite. We said 1 gram to however many kilograms, and we tried to figure out what that would be. And the way we did that was just by sort of looking at this chart and sort of comparing the prefixes and looking at the exponent to see how many decimal places we move. But the point of this video is to sort of clarify which direction we should move the decimal when we are moving it, just in case that's still a little confusing. So let's look at it. Let's say what a kilo is. Kilo is, if we look at our chart, is just 10 to the third, versus the standard is just 10 to the 0. What I do is I compare the exponents and I subtract them. I say, well, what's 3 minus 0? Well, that's just positive 3. And positive 3 is 3 to the right. And that's just sort of my rule. So I take this decimal and I move it 3 places to the right, as it's starting from here, 1, 2, 3. In this system, I would go 3 places to the right, 1,000 grams. And then I do the exact opposite backwards. I'd say the standard is 10 to the 0, and we're converting to kilo, which is 10 to the third. Well, let's compare those exponents. What's 0 minus 3? And yes, I always subtract the first from the second. 0 minus 3 is negative 3. So we'd move this one 3 to the left, which would go from here, 1, 2, 3. We'd get 0.001 kilograms. And that's pretty much the extent of my trick. So let's keep it simple. Let's do another one. Let's say, what if we want to convert, let's say we do 1 centimeter to however many millimeters this is. And I keep it simple so we can test our answer using sort of logic. And what is a centimeter? Well, centi is 10 to the negative 2, looking at our chart. Okay, and milli is 10 to the negative 3. Okay, so what's going on? Well, we're going from negative 2, and we're subtracting negative 3. Okay, so we're going 1 decimal place. We know that because it's from here to here, and the question is which way? Well, 2 negatives make a positive. So it's basically saying negative 2 plus 3. And negative 2 plus 3, well, that's just positive 1. In other words, we go 1 decimal to the right, so this goes from 1 to 10. So 1 centimeter is 10 millimeters. And so now we see that it works even if we're not working with the standard. The trick is just we're subtracting. So if we're subtracting a negative, we need to recognize that that's the same thing as saying plus. So let's try another example. Let's instead of 1, let's make this a little bit harder. Let's say 5. And let's deal with micro this time. That's this weird symbol. That's called mu, so we'll draw that. It sort of looks like a U with a tick in front of it here. Micrometers. And let's say we want to convert that to however many, let's keep it at centimeters, just like the last example. Okay, well, what is micro? Well, micro is 10 to the negative 6. And centi, as we said before, is 10 to the negative 2. Okay, so we're going from 10 to the negative 6 to 10 to the negative 2. Well, that's pretty simple. We just say negative 6 minus negative 2. And as we said before, minusing a negative, 2 negatives make a positive. So this says negative 6 plus 2. If we take negative 6 and we add 2, we end up with negative 4. And so in our little system we're using, we would say then we're going 4 to the left. And so we take this and we move it 1, 2, 3, 4. And what do we wind up with? We wind up with 0.0005 centimeters. Or you could say, well, it's negative 4. So instead of 10 to the negative 6 or 10 to the negative 2, we could say we're taking 5 times 10 to the negative 4. Because that's what our exponent is doing. And if we do that, we get 0.005 centimeters, or 5 times 10 to the negative 4 centimeters, which is actually what scientific notation is. And so just a bonus in this video, that's how that works, and that's actually where that comes from. Sorry about that noise. And so let's try another example. Let's say we want to convert gigabytes. Let's say a gigabyte into kilobytes. So we're using our computer memory terms. So how many kilobytes is 1 gigabyte? Well, if we look, what is a giga? A giga is 10 to the ninth. Okay, 10 to the ninth. And, well, what is a kilo? Well, that's obviously just 10 to the third. Okay, so we're going from 9 to 3. So what's 9 minus 3? And since they're both positives, I don't have to worry about these weird parentheses or negatives becoming positive. What is 9 minus 3? Well, that is just positive 6. So in other words, we move that decimal 6 places to the right. Or we could just say we multiply it by 10 to the 6th. Well, let's just move that decimal places 6 places to the right. We just get 6 zeros afterwards, so that's just a million. A million kilobytes is 1 gigabyte, or we could just say 10 to the 6th kilobytes if we wanted to be scientific notation, or just simplify it. That's all scientific notation is just simplifying it. And so let's do another one. Let's say we wanted to do 0.5. And let's say we were dealing with kilograms, 0.5 kilograms, and we wanted to convert it to milligrams. Well, what would that be? Well, what are we doing? We have, kilo is 10 to the third, and milli is converting to 10 to the negative third. Okay, well, what is that? Well, that's 3 minus negative 3. Which is the same thing as saying 3 plus 3 equals 6. Okay, and where did you get in that? How did you figure that out? Like, why is that negative becoming? Well, if we look, we're going from here, 1. We're starting here, 1, 2, 3, 4, 5, 6 to get to that location. So that's where this 6 comes from, in case you were confused. I'm just sort of proving that math. Well, what does that mean? It means we're going 6 decimal places to the right. Okay. So we take this decimal, we move it 6 places to the right, and we wind up with 500,000 milligrams. And if you're wondering why we don't have 6 zeros, well, it's because we started here as opposed to here, and so we had to lose a 0 because math. And then if we wanted to, we could just, instead of counting how many decimal places to the right, we could write it at scientific notation by multiplying by 10 to the 6th. So what will we get? We get 0.5 times 10 to the 6th milligrams, which would be the scientific notation version of this. And again, that's where scientific notation means. It's just sometimes kind of faster to write when you get really, really big numbers. And I'll show you that in the last example in a second. And technically, the correct way to write this would be 5 times 10 to the 5th milligrams, because that would just move the decimal place 1 place over and give us our decimal. But that's just details. And technically, I guess both are kind of correct. But it doesn't really matter. Let's go ahead and do one more example. Let's say micro. So we start with micro, and let's do 3. And let's say we convert it to however many kilo. And actually, we're probably going to have to move that pretty far over. Let's do liters, microliters to kiloliters. And in fact, I want to drive home an idea. So instead of kiloliters and microliters, let's say we have micro inches, because this would be true for any unit. And this isn't really a unit. There is no such thing as a micro inch and a kilo inch. But if there was, it would work the exact same way no matter what our units are. So that's kind of an important concept to get. So we want to go from micro to kilo. Well, what is micro? What is 10 to the negative 6 versus kilo is 10 to the positive 3. So what are we doing? Well, we're going from negative 6 to positive 3. So we'll say minus 3. Well, what's negative 6 minus 3? Well, that's negative 9. So we're moving the decimal place 9 places to the left, or we're multiplying it by 10 to the negative 9. Okay, so we just take this decimal and we move it 9 places to the left. What do we get? Well, we get 0.0000. We just basically count out how many zeros we need. We have 5, 6, 7, 8, 9, and then we say 3. And then we can just move this kilo inches over. And of course, this is the same thing as saying 3 times 10 to the negative 9 kilo inches, or kiloliters if these were liters, or kilometers if these were meters, or whatever. And in this example, you can see, well, why would we use scientific notation? Well, because this is a lot easier to write than all these zeros. A lot easier to say as well.